Aloha and welcome. In this lesson, we're going to be talking about authentication methods. So we're going to go ahead and open up our courseware. Once we're in chapter unit 2.3, we're going to be looking here at the one-time passwords. So common implementation of the possession authentication factor is going to be one-time passwords, also known as OTPs. These are one-time only use passwords. That's an authentication code that you're going to get. It's between 6 and 10 digits long, and is commonly used by an authentication system that deploys two-factor authentication. A good example of this is Amazon. So Amazon, when they send it, they actually call it an OTP when they send it to you. So if you've not been using, let's say you go a while without using Amazon, or it's been a while since you had to authenticate again, they'll send you basically a message that says, "Hey, we need to send you an OTP. Is this a good place to send it? You know, whether it's email or whether it's a phone, text message, something like that." So they'll send you this one-time password that way. So the OTPs, they're more secure than a password. An OTP, you really can't share it with somebody because it's one-time use and there's a time limitation on it. So it's safer in this way. Also, it eliminates the need to remember a complex password. You just get sent this digit, this long digit, and it's about 6 digits long actually. So you get that, and then you plug that in. There's two types of these OTPs that exist. One is a time-based one-time password, what would they call it? TOTP. And the TOTP, it changes periodically. So it's based on essentially a timer and a secret key. So the timer itself you've got a time step. So every so many seconds, and it's usually between 30 and 180 seconds, every 30 to 180 seconds, it regenerates a value for you. So once it generates that value, it's good for that amount of time, whether it's 30 seconds to 3 minutes. So an example of this is going to be Google Authenticator app. So if you open up Google Authenticator app, or if you've had experience with that, you'll notice that it has a 6-digit number in there, and it has a little clock that counts down. So as your password time goes on, I forget how many seconds it is. It might be 180 seconds, but as it goes, your clock runs down, and then like 5 seconds before it expires, the digits turn red to let you know, hey, this is about to expire. If you're typing it in, hurry up. And then it will go black again once once you hit the end of the 180 seconds or whatever, and it starts a new timer with a new number. So this is referred to as the time-based one-time password, TOTP. The other one is going to be the HMAC based one-time password, the HOTP. Just know that this is event-based. HMAC is a little bit of a long one. So HMAC based one-time password HOTP. The H actually is HMAC. So HMACOTP is a little bit too long, so they just shorten it to HOTP. And HMAC stands for, I believe, was it the hashed message authentication? So that's it's using a hash in there that's it's using a secret key, and then it's using an event, like a counter to actually create this hash number that comes out that you're going to be using. So it too is a one-time password. It's going to change based on that event. That event could be something like a button press or something like that. So you've got a device, the HotP generator device, you push a button, it's going to increment, it's going to change the value that comes out of that you're going to be using. So an OTP can be generated by software application or a hardware device, and it's generally delivered by email, short message service, SMS, or a phone call. So our participation activity here, it's going to have us look at the different types here, TOTP, OTP, and HOTP. Remember that TOTP and HOTP are types of OTP. And then here it's going to test you on the different, on the different ones that they have. And then we get into software-based OTPs. So an authentication application, also known as a software token, is an application that generates an OTP. So you can think of it as like Google's Authenticator is a mobile authentication application that generates a TOTP or a HOTP. I was telling you about the TOTP example before, but it also does HOTPs as well. And you can use the Google Authenticator in Google's two-step verification. I believe Microsoft and Salesforce and a couple other companies make their own authenticators as well for their apps. So an authentication application, it can be configured to use an authentication server. So the authentication server sends a secret key to the authentication application. Usually you're doing something like a QR scan or something like that. Then the secret key is used by the authentication application to generate OTPs for all future authentication requests to the authentication server. So you just have to sync it that one time. It gets that seed or whatever, that secret seed, and then it's using that to generate everything going forward. So we're going to look at our participation activity here. You can see that the application lists the user's account identification, like their email address. This helps you know which one it is. When you get like 10 or 15 of these, or maybe you have two accounts and one for Dropbox or something like that, you'll need that information to distinguish which is which. And then we go in and we hit play, and the TOTP generated by Microsoft's Authenticator application for each service provider. In this case, the TOTP consists of 6 numbers. That's generally what I see in the ones that I use in Google Authenticator. And the time left to expire of each TOTP is it's indicated by this graphic right here, which is the clock, the countdown timer. And once it expires, a new set of TOTP numbers will be generated automatically. It'll turn red for a second, or maybe it'll flash or something. I'm not sure about the Microsoft Authentication app, but after it does, it'll just regenerate a new number that you have to use. So an OTP can be delivered by an email, SMS, or a phone call. You could get a push notification. Push notifications or notifications are sent by authentication servers to a mobile device associated with the user. Push notification informs the user of an authentication attempt with the user's credentials. An authentication attempt is approved if the user performs a specific action, such as pushing a button on the phone, or opening up an application. Google does this occasionally. Sometimes you'll get something that says, "Hey, open up on your phone, open up your Gmail and respond accordingly." So you open up Gmail and it'll say, "Hey, we just had a login attempt from such and such. Is this you?" And you just click yes or no. And then it says a push notification uses a possession factor, like your mobile phone, to validate the user's identity. So here we get into participation activity. We're just matching up push notification, seed, and software token. Again, the software-based OTP, you're going to be just answering questions to solidify your knowledge about that. And then we get into hardware-based OTP. Hardware-based OTP, there's a couple aspects. So security tokens are one. They're also known as token keys, security keys, or password keys. And those are these little devices that you can carry, and they're electronic. They have like a button you can press and it'll generate the number on it. You can, for this one right here, they're showing in the example is an RSA secure ID token. So it's saying here that security token has encoded secret key that is only shared with an authentication server. So the security token does not store an OTP on a network device, such as a mobile phone or an email client, and therefore it's more secure as an authentication method. So that's a positive thing. So this is the RSA secure ID. So you can see right here in the little LED, the crystal display here, you've got the 6-digit number. So an OTP can be pre-generated and used when a hardware software security token and a network does not exist. So you can do this offline. So that static code, it's pre-generated. It's going to be a pre-generated OTP. So static code can be generated by a hardware or software-based OTP generator and then saved on the secure storage device for later use. So this is important. You can do this offline. You can store it offline and use it later. So then you go in here, you match up these keys just like we did above, answer some more specific questions to make sure you fully understand what this is. And then we get into the hardware-based security modules. These are interesting. If you're using a Windows device, this is kind of a big thing right now because people that are running Windows 10, they had just come out with these things called Trusted Platform Modules, the TPM. Most people have like a TPM 1.0 in their Windows 10 systems. The older or the newer ones may have a TPM 2.0 model, but or 2.0 version. But the problem that came about was when you want to update to Windows 11, your system actually has to have a TPM 2.0 module. If you don't have that newer TPM module in there, then you're going to be in trouble because you're not going to be able to install Windows 11. So you're going to have to upgrade all your hardware just to do that. Sometimes the TPM module, it's hardwired onto the motherboard. Other times it's just something that you can pop in. But because of that difference, if you had a hardwired one, you wouldn't be able to just swap out for a new TPM, and therefore, the whole upgrade process would not go well. So you'd have to buy new hardware for that, at least a new motherboard. And when you get a new motherboard, you're often getting new, memory and new CPUs to go with it, and new cooling fans and everything else. So it's an expensive mess if you're trying to make an upgrade from Windows 10 to a Windows 11 system. That's kind of side information there. But anyway, getting back into the hardware-based security modules here. Hardware device can be authenticated to ensure that an unauthorized operation is not performed on data and systems. So we've got two different types of hardware-based technologies that support device authentication. One is the TPM, the Trusted Platform Module. The other is the Hardware Security Module, the HSM. So you got TPM and we've got HSM. So Trusted Platform Module, that's going to be internal on it. So it's a secure processor that performs cryptographic operations. So when you think cryptography, cryptographic, we're talking about cryptography here, we're talking about encoding and decoding things. So a TPM can be embedded on a computer motherboard. It can be embedded, part of it wired onto it, or it can be installed on a computer motherboard that has a TPM port. So if we look at the image here, we've got a Gigabyte Technology one. Gigabyte is a famous motherboard manufacturer. And this one right here, if we were to zoom in on that, you can see that it has these plugs on it. So we do have the ability to just plug this in. So that's nice. It can be plugged, you can plug it in and then replace it, with a different module later on if it supports it. So that's great. So getting back here, it says a TPM has a burned-in RSA key pair which can be used to authenticate a hardware device. A TPM can store cryptographic keys, passwords, and certificates. So it's got that RSA key pair, but it also can store new cryptographic keys, passwords, and certificates on it as well. So TPM, it's tamper resistant, and it can help prevent unauthorized modifications to firmware and software as part of the secure, trusted boot process. So when you're booting up your system, when you first turn it on, it can check your firmware and software and make sure that it hasn't been modified or tampered with. And that's really nice and secure. So an operating system can use a TPM for full disk encryption, also known as FDE. So it uses BitLocker. If you're using Windows, you have the option to do that when you first set up your system. So you can also, I think you can turn that on later too. It'll just take a while to go ahead and encrypt everything. But what's going to happen is if something happens, to your system, or if somebody comes and tries to, if they steal your hard disk and take it away, they're not going to be able to use it because it doesn't have the encryption keys with it, because the encryption keys are back on your system in the TPM module. So, and Microsoft Windows uses BitLocker for that full disk encryption. We also have here hardware security modules. So you see we can have it, if you look at this one, this is when you plug in. This looks like a rack, actually, like an independent rack that you would just plug in for doing the crypto processing. So an HSM module, it's a tamper-resistant external device. So it's going to be outside your system, or it can be this little plug-in expansion one like the first one right here. And it's going to provide cryptographic services. So an HSM can store a hardware device's certificate for authentication. It can store cryptographic keys and passwords. So for example, in HSM, they're used for real-time authentication authorization of credit card and debit card transactions. And of course, that'd be in the payment card industry. They also contain one or more crypto processors inside there for creating, securing, storing, and managing those encryption keys. So a crypto processor, it's a dedicated microprocessor. Microprocessors essentially do one function. That's what microprocessors are, best for. So a crypto processor is a dedicated microprocessor that just does cryptographic operations such as encryption. And then we have it here. It's talking about how a TPM or an HSM, they can be certified against a certain security standard. Like the current one is FIPS 140. So FIPS 140 stands for the Federal Information Processing Standard, FIPS. 140 is the publication series, so it's FIPS 140. So that's the U.S. government computer security standard that specifies what the requirements are for cryptographic modules. So as you come out with, right now it's, it meets the FIPS 140. If they change the specification demanding higher security, then of course newer versions, they'll change the hardware, change the firmware, software, whatever they need to get it compliant with the higher standards. And then you go and you can see we've got matchup for HSM, TPM, FD, and crypto processors. And over here, they have you just do some fill in the blank or choose multiple choice type things. The last thing here is a secure enclave. Secure enclave is kind of similar to what we've talked about before, but secure enclave, it's a tamper-resistant hardware component isolated within a system or device that provides a secure environment for cryptographic operations. You hear about these on like the iPhone and things like that. So you've got this secure enclave and ensures that the sensitive data remains encrypted and inaccessible to the other hardware, including the operating system. So secure enclaves, they enable devices to comply with data protection regulations, such as regulations for data rights management and secure payment processing. So that's what a secure enclave is. It's that little isolated area in your system that does that the cryptographic operations. So that is it for this section. I've got two videos that I looked up because I thought you might want a little bit more information on a couple of these things. So for HOTP and for, let's see, I think it was the Secure Enclave, I came up with a couple of videos. I'm going to put it down in the remarks below. So check that out. It'll have a couple of links to other videos that I found helpful in explaining some of these concepts. Because a lot of these tools, so whenever we have things that are not really readily available, we can't just open up our computer and look at it, or if we need a little bit of help understanding it because it's not something that we come across in daily life, I'm going to try to come up with the videos that are already out there that explain it a little bit better. So I'm going to drop two videos in the comments below. So take a look at that, and I will see you in the next video. Aloha.